Children, now we are going to learn about acidity of alcohols. What is meant by acidity? According to Lowry-Bronsted concept, a compound which donate H plus ions or acids. So, for example, HCl. This is an inorganic acid. Organic acid means CH3COOH. These are called acids. Why they are called acids means because they can donate proton, that is H plus ions. So alcohols can also donate electrons. Alcohol means ROH. It can also donate proton, so it is also acidic in nature. Why it is acidic in nature? Because it can donate protons. So how it can become acidic in nature? The bond between in ROH, the bond between O and H, it is polar in nature, so it can donate protons, but they are weakly acidic when compared to water. Water we can able to drink. So such a weakly acidic water, when compared to that, alcohols also weakly acidic than water. H2O, if you are seeing, it can act as acidic as well as basic. Acidic means they can donate protons. Basic means they can accept protons. So water also acts as amphoteric in nature. Acidic and basic, according to Lowry-Bronsted concept only. So all the alcohols are weakly acidic than water, except methanol, CH3OH, which is strongly acidic than water. This reason we can see later. Now, alcohols, ROH, water, HOH, both having OH group. So, how will we prove that alcohols are acidic in nature? There are some evidences. Evidence 1. If you are seeing, for example, acetic acid, one of the acid, CH3COOH, when treated with sodium, it forms sodium acetate plus hydrogen gas is liberated. Two molecules reacting here. From this, 2H2 is liberated. Similarly, if you are, this is called sodium acetate. Now, suppose alcohol ROH, it also can react with sodium, forming RONA plus H2, sodium alkoxide. So it can behave like acid because it is donating protons. Now, same acid, when treated with sodium hydroxide NaOH, it gives salt and water. But alcohols will not react with NaOH, do not react with NaOH. This is the evidence 1 to show how alcohols behave as an acid. Now, second evidence, one more evidence we can see. For example, Ka value. Ka means dissociation constant. If Ka value is greater means it is strongly acidic. Lesser means weakly acidic. For example, Ka dissociation constant for water, H2O, 1.8 into 10 power minus 16. For alcohol, 1.8 into 10 power minus 18 to 10 power minus 16. So comparing the both, the power which is lesser, power which is greater, power which is greater, uh, having the smallest value. So water, the Ka value is more. So water is more acidic than alcohols because of this reason. Water is more acidic than alcohol. So it is said that methanol, which is greater than water, which is greater than other alcohols. Here for methanol, the Ka value is 3.2 into 10 power minus 16. This one is 1.8 into 10 power minus 16. So the Ka value more means acidic. So methanol is here. The methanol is more acidic than water. Now consider the three alcohols: primary, secondary, tertiary. Primary means already you know, having CH2OH group. Secondary you know, CHOH group. Tertiary you know, COH group. Then this alcohol, carbon carrying alcohol bonded to a methyl group. Secondary means bonded to two methyl groups. Tertiary means bonded to three methyl groups. Primary, secondary, tertiary. Three having acidic character only, acidic nature only. But which is having more, which is having less? This is a question. Primary having one alkyl group, secondary having two alkyl groups, tertiary having three alkyl groups. So when come into account here, there are two type of effect. One is my inductive effect. Among the inductive effect, there are two types: minus I effect and plus I effect. Minus I effect means minus I effect plus I effect. Plus I effect means electron, the groups will release electron release groups. Plus I, electron withdrawing groups. Plus I electron release, minus I electron withdrawing. For example, Cl, F, Br, these and all electron withdrawing. Alkyl group, electron releasing groups. Electron releasing groups. See here, one alkyl group here, it will release the electrons, and here from here the electron released here, then from here electron released here in between O and H. So here electron density get increased here in here OH. So bond becomes stronger. So H cannot come outside. So acidic character decreases. When compared here, two methyl groups releasing electrons, both coming here. So this bond becomes more stronger when compared to this one, because alkyl groups are electron releasing groups. Plus I effect. Here you see three methyl groups. So three of them releasing electrons. So these electrons come here and come here. Electron density is still much more, and still acidic nature decreases. So because of this, primary greater than secondary, then last one only tertiary. Because of this reason only, because of this inductive effect only, this is acidic, then it is more acidic, then it is still acidic character get decreased because of the alkyl groups. This is one of the evidence for measuring acidic character. Tertiary, then only secondary, then only primary. Even Ka value for primary is 1.3 into 10 power minus 16. For secondary, 3.2 into 10 power minus 17. Here Ka value for this one is 1 into 10 power minus 18. So this is less. This is more acidic, this is less. So alcohols, when compared to three kinds of alcohols, primary, secondary, tertiary, primary alcohol is more acidic when compared to secondary and tertiary. When compared to methanol and water, CH3OH, CH3OH and water, CH3OH will be greater than when compared to water, because one evidence I can show. For example, CH3OH on dissociation giving CH3O minus methoxide plus H plus ions releasing protons. But water also H2O giving OH minus ions, hydroxide ions plus H plus, both can donate. But according to Lowry Bronsted concept, methoxide, here hydroxide, this also behaves as conjugate base. Because since it can donate protons, after donating protons, the remaining compound, that is called as conjugate base. But when compared to OH minus and CH3O minus, CH3O minus is weaker when compared to OH minus, because of this case. This is more stable when compared to water. The value also already I told, Ka value, because of that reason this is more stronger when compared to water as well as we are drinking, so such a weakly acidic. So based upon that fact, methanol is more acidic when compared to water. Similarly, questions will be asked. Alcohols also, due to this reason only, due to the inductive effect, plus I effect, minus I effect only, that is electron releasing groups, electron withdrawing groups. Based upon that, methyl groups, alkyl groups, electron releasing groups, the order goes like this: primary, then secondary, then tertiary. It is given in a book, page 123, but such a long will not be explained in the book. It is only simple. You can go through the video as well as you can mark in the book. One more questions will be asking: what is electron withdrawing groups? What is electron releasing groups? Why primary, secondary, tertiary? There is comparison of acidity between them. Why they are acidic in nature? Such a way it will be asked. So you go through the book and you can mark.